Now, let's talk about energy transfer in a chaparral food chain. All right, so this shows the energy transfer among specific organisms. That's what a food chain is. Now, the sun is the main source of energy. And so, as the sun or the photons hit the leaves of, let's say, this California buckwheat here, it's going to go ahead and go through a process called photosynthesis, where it takes CO2 from the air and it takes water up from its roots, and then it uses the photon or the energy from the sun through a process called photosynthesis, and it's going to make glucose, which is a energy storage molecule, and oxygen. All right, so let's take a look how this works. So here's the glucose molecule, and then as you can see here, we've got the bush rabbit, and the bush rabbit is a herbivore. It only eats plants, and it's a primary consumer. So as it feeds on the California buckwheat, those energy or that biomass or those glucose molecules are going to be transferred to the rabbit. Now, not all of it's transferred. Again, some of it's lost in heat, the energy. And then also some of the matter is lost through maybe it's shedding some of its hair or its excretory system where, it goes to the bathroom, scat, right? So some of that's going to go into the soil and some of the energy is going to be lost in heat. But that energy that once it eats that plant is going to be transferred there. And then from there, we have the coyote, which is an omnivore, which will eat plants or animals, and it's a secondary consumer. And so as it feeds on the bush rabbit, those energy storage molecules, the glucose, are going to go ahead and be transferred to the coyote. Again, remember that a food chain shows energy storage transferred among specific organisms. All right, now let's talk about the energy transfer in a chaparral food web. So let's kind of just populate this through our cards that we have. Again, here's all my cards. So I'm using, you have access to all of these and all the facts of what they eat. So we're going to be creating our food web here. Remember, the sun is the main source of energy. And so as the sunlight hits the leaves of the plants, whether it's the chamise or the California buckwheat or the Mission manzanita or the California or the scrub oak, the coast scrub oak, it's going to photosynthesize and it's going to make biomass. It's going to make this glucose or these energy storage molecules. So remember, in a food web, it shows the energy transfer between all organisms in an ecosystem. And the ecosystem that we're talking about is the Ramona Chaparral ecosystem, which we've been studying. Okay? So let's take a look at the relationship between everything. This took me quite a while. Again, you're going to be later on spreading out these cards and seeing what eats what. It's really fun and exciting to learn more about the amazing wildlife and organisms that we have in our own backyard here. So let's get started here. The arrows don't show who eats who. So for instance, if you look right here, this little big-eared wood rat is not going to pounce on this gopher snake and eat this gopher snake. Or over here, you're not going to have, let's say, this Mission manzanita or chase down this coyote and attack it and eat it. So this is not eating this. What's happening is the arrows are showing the flow of energy from one organism to the other. So as this coyote is feeding on this bush rabbit right here, the energy from the bush rabbit will go to the coyote. Or as this coyote feeds on the Mission manzanita berries, because it's an omnivore, the energy storage molecules, right, the biomass, the glucose, will go from here and be transferred to here. Or as this red-tailed hawk feeds on this gopher snake, all of those energy storage molecules in the body of the gopher snake go into the red-tailed hawk. Or as it feeds on the roadrunner, that goes into the red-tailed hawk there. All right? So, the other thing you should be familiar with are these terms here: herbivore, carnivore, and omnivore. All right? So, herbivore, let's take a look here. All right, so we've got, here is the mule deer. So this mule deer, I'm looking, the only arrow I see is this arrow going from chamise to the mule deer, meaning that the mule deer solely feeds on chamise. It doesn't eat any animals. It just eats the producer, the plants, or the autotrophs. So that makes it an herbivore. Let's see if we can find another herbivore. Oh, this bush rabbit here feeds on the California buckwheat. So that's going to make that bush rabbit an herbivore. And it looks like this big-eared wood rat is feeding on the acorns of the scrub oak. So herbivore here. All right, let's take a look at carnivore. So we'll go straight to the mountain lion here. What does the mountain lion feed on? The mule deer. Mountain lion feeds bobcat. Mountain lion feeds on coyote. Mountain lion could feed on a gray fox. So it's eating just animals. So that would make it a carnivore. And let's take a look omnivores. So we've got this western fence lizard that's feeding on these harvester ants. So that's an animal. But also it's feeding on these tiny little seeds in the flowers of the California buckwheat. So that would be a plant that it's feeding on. So because it's eating an animal and a plant, that makes it an omnivore. Let's take a look at the coyote. Coyote could feed on the rabbit. Coyote could feed on this bird here, this scrub jay, but also is feeding on some plant material, so making it an omnivore. This lizard feeding, we already talked about that, didn't we? All right, so those would be some omnivores. Now, let's take a look at this. If the coyote was overhunted, so let's just take a look at question 1 here. If the coyote in this chaparral food web were overhunted, resulting in no more coyotes, what would happen to the bush rabbit population? Okay, what would happen to the bush rabbit population? Second question. What would happen to the Mission Manzanita population if coyote is overhunted? So again, 2 questions. Please think about this scenario. You've got enough understanding to figure this out. So go ahead and pause the video and let me know what would take place. No, really, pause the video. All right, so let's take a look. So if the coyotes are overhunted, what's going to happen to the rabbit population? Well, we know they feed on the rabbits quite a bit. So if they're gone completely, that rabbit population is going to explode. It's going to go up. So that could also possibly create more resource population for the bobcats. So maybe theirs could slightly get a bump and go up. Or anything else feeding on here, whether even a mountain lion feeding on the rabbits. Let's take a look. What would happen to the Mission Manzanita plant? Well, if there's no coyotes feeding on the berries, that's going to leave more resource population for the ants. Harvester ants could go up, or this lizard population could go up. And if that lizard population goes up, then maybe this rattlesnake population could go up because there could be more food here. So it's kind of this cascading effect. They call it trophic cascading. Now, this is a photo from Oregon where they had a competition to see how many coyotes they could kill in one 24-hour period. I think they killed 150 coyotes. Ranchers really look at them as pests and as a predator, and they want them wiped out so that they don't attack their livestock. So again, here are a huge amount of coyotes killed in one day. Now, there's a book called Living with Coyotes. Stuart R. Ellens, and basically he talks about right here that in the 70s in Bakersfield, California, a lot of the ranchers were really just annoyed with the amount of coyotes, so they went out and they just killed tons of coyotes and shot them. But what they didn't realize is once they killed all the coyotes, or many of the coyotes that were attacking their sheep and the lambs, right? They were losing a lot of their livestock. Then what happened was the rabbit population exploded. You can see right down in here. And then the other farmers that were farming with the alfalfa fields were really upset because there was no predator, the coyotes, to keep the rabbit population in check. So they exploded out of control and then were eating a great majority of the alfalfa crops. So again, when you mess with one part of the food web, it has these cascading effects. And so again, the book does a great job of explaining how they can use this thing called food aversion conditioning that works, where what they would do is take, let's say, a dead sheep or even a dog or a cat, and then they would put this lithium chloride, which wouldn't kill the coyotes, but make them really nauseous and sick. So when they'd feed upon that dead animal, they'd get really sick, and then it would condition them not to feed upon that certain livestock. And there was some evidence, quite a bit of evidence, proving that this worked better than just going out there and hunting and killing all the coyotes. Now, back to this here, reading a food web. You need to be able to kind of practice, like if the red-tailed hawks were taken out, or let's say that there was a pesticide in Ramona and it killed some of the California buckwheat. What would happen? Or maybe there would be like some type of abiotic factors, like a drought, or maybe El Nino year and we got a huge amount of rain. What would happen in the food web when some of these abiotic factors would change? Or maybe a volcano and ash goes up and blocks out the sun in a certain area, and now there's not as much photosynthesis taking place, and then there's less biomass being produced. So let's take an example from the outback of Australia. So go ahead. This took place in the outback of Australia, and there was this town that was overrun by these mice. They call it a mouse plague. It was unbelievable. Take a look at this footage.
Experience was so unbelievable, they got out their video camera and recorded the raid of rodents.
Here we are, this is the mice coming out of the small pig shed.
Oh, they're in my boots!
Can you hook the door up and go?
Got the lights on as well?
Yeah, you can go in if you can.
How do I...
Oh, you can't?
Oh, yeah!
Like when Mum opened the door, it was just flowing out with mice. She got one up in her jacket.
When Mom got at the door, she was filled with mice. One got in a jacket. That's crazy. So what happened in this town in the outback of Australia is these monsoon rains came, and they got these torrential rains. They got so much more water. Remember, water is an abiotic limiting factor, but they got extra water that year, so much that the plants had more water to be able to photosynthesize, right? And so there was more crops, there were more plants. That means there was more resource population for the mice. They just ate, and what do they do really well? Reproduce. And so there was this mouse plague. It was out of control. So again, they actually had to bring in this huge scale poisoning thing to get rid of them because they were starting to eat the pigs. The mice were eating the pigs. The mice were just out of control. The farmer was trying to start up his tractor, and the engine was seizing because it was just full of mice. So things can get out of whack either through human impact or just a natural impact with abiotic factors, as we've mentioned. So remember, the sun is the main energy source. And then obviously there's the producer. Down here you can see all of our producers, right? And then from there we've got our consumers, which are right in here, whether they're primary, secondary, tertiary, or quaternary consumers. And then last we've got is our decomposers, which are mainly made up of like nematodes or earthworms or fungi or bacteria that break down plant and animal matter material. So let's just kind of take a look at one here. So we've got the scrub oak, and then from the scrub oak we've got the big-eared wood rat that eats the scrub oak, and then from there we've got the gopher snake eating the big-eared wood rat, and then we have the road runner. And the roadrunner is eating the gopher snake. So let's see. This would be the primary consumer. This gopher snake would be the secondary consumer. The roadrunner would be the tertiary consumer. And then we've got the coyote eating the roadrunner, which would be the quaternary consumer. And then we've got the mountain lion feeding upon the coyote, which this is the keystone predator or the apex predator, or the top predator there. Again, remember, it used to be the grizzly bear, California grizzly bear, but those are extinct now. And then lastly, we've got our decomposers. So we've got the fungi. Once this mountain lion dies, it will start to break its body down and break all of those matter back into the soil. And then those nutrients will go back into the soil, and then the producers will use those nutrients, and again, water and CO2 from the air, and the energy from the sun to create more glucose or energy storage molecules, and then the cycle continues. So that's the flow of energy and matter in this